Hello students, in this video we will learn about lenses, few important topics on this, that is image formation, lens formula, magnification. Basically on these topics help you out to find out or to solve the numericals. Okay, and we will discuss some of the previous year question in this video. Okay, so let us start. First of all, let us understand what is a spherical lens. Okay, it is nothing but children, a transparent medium bound by two surfaces, of which one or both surfaces are curved. What does it mean? What it is exactly saying? It is the transparent medium bound by two surfaces. Like this is one of the surface, this is another surfaces. So they are clubbed together, bound by two surfaces, of which one or both surfaces are curved. Okay. So in our class, in class 10, you are just going to discuss, your syllabus is having both the surfaces are curved part. But you should know what are the different types of spherical lenses. So it is of two types. You already know concave lens and convex lens. It is a spherical lens. What is concave? It is a spherical lens in which two surfaces are bulged inwards like this one. Okay, these are bulging inwards, right? So it is also called diverging. Now it is just the opposite of mirror. In case of a concave mirror, we know that is a what converging mirror. But in case of lens, just the opposite. But the natures are similar. Concave lens is similar with convex mirror. Okay, we will study in further video. We will discuss regarding all of them. So convex lenses are what? It is a spherical lens in which two spherical surfaces bulge outward. So this is the outward bulging. It is also called converging lens. So basically, let us understand that what are the basic difference between this two type of lenses. First of all, convex lens. Convex lens thin from the corner. This part is thin, and whereas the concave lens, it is thick at the corner part. Then the second point says thick at the center. In case of convex lens, it is thicker. Just see, it is thicker. This distance it is talking about, and it is thin. In case of concave lens, it is thin at the center. And in, convex is converging and concave is diverging. You have to remember this now. We already discussed in the definition part. So just basics, these three difference you have to remember. Okay. Now, what are the different types? As already I told you that double convex is simply we say that convex, and another one is double concave, that is simply you can say concave lens. Now, if one side is a plane one, then we say this is a plano convex, and this particular one you just check, and both of them are bulging inside inwards. Then we say that because it is a convex lens, it is converging in nature. So this type of lens is known as converging meniscus. Similarly, in case of concave lens, first one is double concave or simply concave. Already I told you. Now, if one part is a plane and other part is a concave part, then that one we say that plano concave. Similarly, if the plane part is now curved, then we say that is a diverging meniscus. I hope this is clear. Now let us move the further topic. Now, refraction applied by spherical lenses. We already discussed that spherical lenses, convex one is converging in nature. How we are saying that this is converging in nature? अब देखो यहाँ पे this is the principal axis. यहाँ पे कंस्ट्रक्शन को थोड़ा समझने की कोशिश करो, क्योंकि ये ऑलरेडी जो हमने मिरर में पढ़ा था ऑलमोस्ट वही सिमिलर है. द हियर जस्ट दिस पार्ट इज द अपर्चर. ओके, एंड दिस इज द प्रिंसिपल एक्सिस. प्रिंसिपल एक्सिस क्या होता है? जो ये देखो, ये जो पर्टिकुलरली कॉन्वेक्स लेंस है, isn't it a part of a big sphere? Similarly, this side, if this side we will consider, that is also a big part of a it is a part of a big sphere, isn't it? So now both the sphere have center, isn't it? This if you will see this left one side, this is the center of curvature, and if you will see right hand side, this is the center of curvature. Okay. Now the aperture of this lens and the principal axis, where they intersect, that part is known as O, that is optical center. Okay, it is written. Now optical center, and this is the center, this is all optical center, this is center of curvature. In between these two, what is the midpoint? That is a focus. So here we are having, because it is a mixture of or combination of two spherical lenses. Here this is a part of the circle, this one is a part of another circle. So we are having two center of curvature. Similarly, two focus point we are getting. So from the left side we will start. This is F1, and this side it is F2. Okay, suppose here from O to F1. Okay, whatever is the distance, F1 to C1 is also same distance. So in case of lens, we call it as 2F1. Similarly, on this side, it is 2F2. Instead of center of curvature C1 and C2, we use this particular term in lenses. Okay, 2F1 and 2F2. I hope this part is clear. So now here, why it is converging? Because this lens has the nature when the rays are parallel to it. Parallel to it means to the principal axis. Then after reaching to the aperture, it will converge. After refraction, it will converge and meet, all the rays meet at a point that is called focus. Right? Similarly, in case of concave lens, it is diverging in nature. Why? Because after when a ray parallel to the principal axis reaches to the concave lens, that diverges. Okay, diverges, but after refraction it appears to come from refracted from the focus. I hope this part is clear, and that is how it is in case of lenses. Convex lens is converging in nature, and in case of concave lens it is diverging in nature. Okay, let us move to the next topic. What are the rules? Let us see. Like we had studied for mirror. Here, the first rule, just see a ray of light from the object. First rule says what? A ray of light from the object parallel to the principal axis after refraction from a convex lens passes through the principal focus on the other side of the lens. If it is here, this one just check. If it is parallel, it will after refraction meet at the focus or passes through the focus on the other side of the lens. On the other side means the ray is coming from this side, left side, lens is in the mid, and after refraction it is passing through f2. So we are seeing the other side in the sense the object is on the left side of the lens, so right side of the lens we can consider. Similarly, in case of concave lens, what is happening here? The same thing we had just now we had discussed regarding the converging and diverging nature of both the lenses. Same thing when it is parallel after refraction, when it is the ray is parallel to the principal axis after refraction, it appears to come from or refracted from the focus on the same side. Here this is the difference. It is in case of convex, the refracted ray passes through the focus on the other side of the lens. Here in this case, in case of concave, it is appear to refracted from the same side, means object जिस साइड पे है तुम्हारी इमेज भी उसी साइड पे बनेगी. Let us see later on, but till now this is what we can conclude, because we have already have the knowledge of in case of mirror, image formation in case of mirror, so we can conclude this. Now the second one, just the reverse one. Here you can see that if any of the ray is passing through the focus, okay, if any of the ray is passing through focus after refraction, means it passing through the lenses, so that is the refraction point. So after refraction it will be parallel to whom? It is parallel to the principal axis on the other side of the lens. I hope this is clear. Similarly, when a ray is moving towards the focus, or it is reaching to a concave lens after refraction, it will refracted by making parallel rays with the principal axis. It appears to as if it is appear that it is moving towards focus. Okay, f2, right? So what is the third point, third rule? Let us see. This is the third rule. A ray of light passing through the optical center of a lens will emerge without any deviation. That means when it passes through optical center, it will pass just like that without deviation. Okay, so that means we can also say there is no refraction in this case, but it is just simply pass away, okay, through that particular optical center. It is happening same for both the lenses. Okay, that's it. In the three rules are there in case of spherical lenses. So any two rule we will follow to make an to find out the position of the image, right? Let us move to the first one. In the first case, in case of convex lens, we will see first case, if the object is placed at infinity, what happens? All the rays must be parallel to the principal axis, isn't it? So on the other side, it will converge at this point. One ray, because we know that in case of infinity, all rays are parallel. So only one rule, that follows only one rule out of the three rule, only one rule it will follow, because this conditions is that if whenever there is an object at infinity, all the rays must be parallel to the principal axis, or just the rays are parallel to each other. So we have only parallel to the principal axis case in our NCERT book. So we are I'm just going to follow this one only. Okay, now from this you got it that what are the image position? It is formed at focus, that is f2, or you can say on the other side of the lens. Now this object is actually meeting, this image is forming at a position by the intersection of the refracted ray. So this has to be real and inverted, but you are not able to see that image because it is a point size. We can also say it is highly diminished or point sized. I hope this one is clear. Let us move on to the second case, when the object is beyond 2f1. Now just see children, the object are moving towards the what? Towards the lenses, towards this side. It is moving slowly. In different cases you will see that it initially it was in the infinity, now it is beyond. We can see the object, so beyond 2f1 we are seeing. Okay, so let us see, it is in the beyond 2f1 case. Two rays we have to take to get an intersection point, isn't it? So we are going to, this is the object, we are going to follow. One is parallel, it will pass through focus on the other side, right? It is through f2. Now another one we will take, that is the third rule, it is passing through the optical center. So after intersection you will get the point in between the f2 and 2f2, right? So just make the image here, it will be actually emitting, so it is inverted one, isn't it? So this is what we have written, this is the position, it is really inverted, and because the size is smaller than the size of the object, so image is diminished. Isn't it the cases or whatever we had seen in case of concave mirror? Yeah. So let us move to the third case, when an object is at 2f1. Okay, 2f1, isn't it the case of center of curvature? So it has to be whatever is the nature, it will be equal or the similar one. So just let us see that whether convex lens and concave mirror are equal in nature, almost equal in these cases, except the fact that that is a mirror and it is the lens, right? When the object is at 2f1, so here object we had kept two cases, we have two rules we have to follow. One is parallel, it will pass through focus, and then through optical center. Optical center, whenever they are going to meet, that point is the intersection point is the image place, right? So you got that image is formed at 2f2. This image has to be real and inverted one because they are actually meeting. Image is of same size that of the object. That is what the case when the object was at center of curvature in case of mirror, isn't it? So let us see the next case, that is case number 4, when the object is in between f1 and 2f1. Okay, now at this position, first we had seen infinity, beyond 2f1, at 2f1. Now this is the fourth case, right? Two cases, two rules we have to obey, two rays we have to take. One is through focus, another one through principal axis. Children, you take your pencil and try to draw it again and again so that it will be a practice, and this nature, whatever nature we are writing here, that has to be crystal clear in your mind, right? So children, just first of all, just see that this intersection point is at beyond 2f2, right? So here the image formed as beyond 2f2, the image is real and inverted because actually emitting, so it has to be real, and real with real always inverted terms comes, you know, and it is inverted also, isn't it? ये उल्टा है, प्रिंसिपल एक्सिस से अगर आप देखो तो ये उल्टा दिखता है, so it is real and inverted, and image becomes larger. Okay, so it is larger from whom? From the object. So जितना पास पास ये ऑब्जेक्ट लेंस के पास आ रही है, उतना दूर दूर इमेज फॉर्म होता जा रहा है और धीरे धीरे इमेज का साइज बढ़ता जा रहा है. दैट यू हैव टू रिमेंबर. बट इन केस ऑफ मिरर क्या होता था? मिरर में जितना पास पास ऑब्जेक्ट जाता था उतना उसी साइड में इमेज धीरे धीरे दूर जाता था उससे. ओके, और साइज भी बड़ा होते जाता था. Okay, I hope it is clear to you all. Let us move on to the next case, that is case number 5. Okay, here the object is at focus now. Okay, f1. At f1, what will happen? Both the cases we will see. Now we will see that they are, after refraction, they are parallel to each other. So we know that if two rays are parallel, that means what? They must be, there is a point from where they are coming. That means there is an intersection point at infinity. लाइक फर्स्ट केस में क्या देखा था हमने? इन्फिनिटी से ऑब्जेक्ट का रेज आया हुआ है और बहुत दूर ट्रैवल करने के बाद ये एक पैरेलल रे हो जाती है. सिमिलरली ये पैरेलल रे बहुत दूर जाके कहीं पे मीट करेगी, जो हमें दिखेगी तो नहीं, बट ये एक हमारे नॉलेज में है. इज वी कंसिडर दिस एज इट इज़ गोइंग टू मीट समवेयर, बट दैट पॉइंट इज इन्फिनिटी, राइट? एंड बिकॉज ये मीट कर रही है तो ये रियल एंड इन्वर्टेड है. इसको हम क्या नाम देंगे? इट इज़ इन्फिनाइटली लार्ज, एंड और वी कैन ऑल्सो से इट इज़ हाईली एनलार्ज्ड. ठीक है, क्योंकि ये पॉइंट ही था, हमें दिख नहीं रही है. ऑब्जेक्ट का साइज अगर ये है तो ऑब्जेक्ट इज दिस मच, तो साइज मस्ट बी हाईली एनलार्ज, बहुत ही बड़ा होगा. ओके, नेक्स्ट केस एंड द लास्ट केस वी विल सी, दैट इज केस नंबर 6, व्हेन द ऑब्जेक्ट इज प्लेस्ड इन बिटवीन फोकस f1 एंड ऑप्टिकल सेंटर O. एकदम पास आ गई है. अब जब मिरर के केस में भी एकदम पास आ जाती थी, क्या होता था? इमेज बनता कहाँ था? बिहाइंड द मिरर. ओके, सिमिलरली यहाँ पे भी देखते हैं इमेज कहाँ बनता है. दो केस लेंगे, अगेन दो रे लेंगे, आई मीन टू से. सो पहला क्या है? पहला रे पैरेलल लेके प्रिंसिपल एक्सिस के साथ, ये फोकस के थ्रू गया, और दूसरा हमने ऑप्टिकल सेंटर के थ्रू लिया. व्हेन यू विल ड्रॉ चिल्ड्रन, यू विल फाइंड दैट दिस टू रे आर डाइवर्जिंग इन नेचर. वो कभी नहीं मीट करते. डाइवर्जिंग जो रेज होते हैं वो आगे जाके कहीं मीट नहीं करते, तो इंटरसेक्ट वो करेंगे नहीं. तो वी कैन एक्सटेंड इट बैकवर्ड. ओके, बैकवर्ड जब हम एक्सटेंड करेंगे तो हमें एक इंटरसेक्शन पॉइंट मिलेगा. ठीक है, तो वी कैन टेक इट ए वर्चुअल पॉइंट फ्रॉम वेयर इट माइट हैव कम. ओके, तो यहाँ पे क्या होगा? ऑब्जेक्ट, ये जो इमेज है कहाँ बनेगा? ऑन द सेम साइड ऑफ द लेंस एज दैट ऑफ द ऑब्जेक्ट. ऑब्जेक्ट जिस साइड में है, इमेज भी वही साइड में है. बट ये क्या है? क्योंकि ये इमेजिनरी पॉइंट है, ये एक्चुअली दिखता नहीं है हमें, बट यहाँ से आया होगा. हम इसको ही एक इंटरसेक्शन पॉइंट हमें फाइंड आउट करना होता है जहाँ इमेज फॉर्म हो रहा है. ओके, हम इमेज का पोजिशन वहीं देते हैं. So now we can conclude that it is virtual and erect, and images, because you can see also from your diagram that it is image is enlarged. Okay, with this the cases of image formation by convex lens is over. Let us move for the concave lens. Children, it is just like your convex mirror. जैसे उसके केस में 2 ही पोजीशन हो सकता था, एक इन्फिनिटी और बाकी इन्फिनिटी और पोल के बीच में, राइट। यहाँ पे भी इस केस में भी ये देखा गया, एक इन्फिनिटी के केस में जहाँ जब ऑब्जेक्ट इन्फिनिटी में है तो एक टाइप का इमेज जो बन रहा है या फिर उसका इमेज का पोजीशन है वो कुछ मिला, और बाकी कोई भी जहाँ से हमें ऑब्जेक्ट बियॉन्ड और यू कैन से इन्फिनिटी से लेके ऑप्टिकल सेंटर के बीच में कहीं पे भी हमने ऑब्जेक्ट को रखा, एक ही नेचर का मिला, राइट। सो इसीलिए इस केस में 2 ही केसेस होते हैं। फर्स्ट क्या है, व्हेन द ऑब्जेक्ट इज एट इन्फिनिटी, और इसका नेचर हम क्या जानते हैं, कॉन्केव लेंस का ये डाइवर्जिंग है, और 3 केस में से 3 रूल में से 2 रूल हम लेने की कोशिश करेंगे, बट इन्फिनिटी से तो हम जानते हैं जितने भी रे हैं वो पैरेलली होंगे, ओके। सो ये 2 रे हमने, ये रे और ये रे को हमने लिया पैरेलली। अब ये डाइवर्स तो होंगे बट इट इज अपीयर एज इफ इट इज रिफ्रैक्टेड फ्रॉम द फोकस पॉइंट। तो यही ये जो सेम साइड का फोकस है F1, वहीं से निकला हुआ और रिफ्रैक्टेड जो रेज है वहाँ से निकला हुआ है, ऐसे दिखाई देगा। सो दैट इज द पोजिशन ऑफ द इमेज। सो व्हाट वी कैन से दैट इट इज फॉर्म्ड एट फोकस, बिकॉज ये देखो डॉटेड लाइन हम दे देते हैं, ऐसे भी हम देख रहे हैं, हम होगा मतलब ऐसे हुआ होगा, तो मीन्स ये क्या टर्म है, ये हमारे वर्चुअल और इरेक्ट है, एंड इट इज हाईली डिमिनिश्ड और पॉइंट साइज। आई होप दिस वन इज क्लियर चिल्ड्रन। लेट अस मूव टू द सेकंड केस, when object between infinity and optical center of the lens, as I told you, बाकी जो भी पोजीशन में आप रखोगे ये सेम ही पोजीशन मिला, तो आप ड्रॉ करके भी देख सकते हो, डिफरेंट पोजीशन में ऑब्जेक्ट को रख के बियॉन्ड 2F1 रख सकते हो, 2F1 के जगह पे रख सकते हो, यू विल फाइंड दिस ओनली, okay। So just check it out once for your confirmation, but I'm saying you that infinity और optical center के बीच में जहाँ हमें ऑब्जेक्ट दिख रही है, कहीं पे भी ऑब्जेक्ट को रखो, you will find image like this, the nature of the image will be this only, okay। So first of all एक पहला हमने लिया एक पैरेलल लाइन जो कि हमें दिखा रिफ्रैक्टेड रे फोकस से आया हुआ है, डाइवर्जिंग इन नेचर, वी नो इट। नाउ थर्ड रूल को फॉलो करते हैं, ऑप्टिकल सेंटर दोनों ही लेंसेस में क्या होता है, दोनों ही ऑप्टिकल सेंटर से सीधा सीधा आगे निकल जाते हैं, ओके, डेविएट नहीं, रिफ्रैक्टेड नहीं होते और अपना पाथ डेविएट नहीं करते, राइट। सो उनका जो इंटरसेक्शन पॉइंट है ऑब्जेक्ट के सेम साइड में ही मिला हमें, ठीक है। अब ऑब्जेक्ट के सेम साइड में मिला तो क्या है, ये वर्चुअल और इरेक्ट है। पोजीशन हमें कहाँ पे मिल रही है, ये ऑप्टिकल सेंटर और F1 के बीच में, ये दोनों के बीच में ही मिलेगा, कहीं पे भी रखो ऑब्जेक्ट, अगर इन्फिनिटी ऑप्टिकल सेंटर के बीच में रखोगे तो इसका पोजीशन हमेशा फोकस F1 और ऑप्टिकल सेंटर के बीच में ही रहेगा। इज दैट क्लियर? द नेचर इज वर्चुअल एंड इरेक्ट एंड इट इज इमेज इज डिमिनिश्ड मतलब ऑब्जेक्ट के साइज से छोटा। इज दैट क्लियर? So let us move on to the next topic. Here in the lens formula, we have to just remember derivation is not required, as I have already written for your class. Okay. We know that in mirror formula, it was just 1 by V plus 1 by U equals to 1 by F. So here there is a change, 1 by V minus 1 by U equals to 1 by F. So you have to remember this children because it is going to help you out for the numericals. Now magnifications में भी हमने जो पढ़ा था, क्या पढ़ा था, HI by HO. So if this is H dash is here, that height of the or size of the image only, by simply H is height of the object. Here this second formula, do you remember, in case of mirror the magnification is minus B by U. This is what we studied. Here there is no minus sign, only this much you have to remember. Okay, I hope this is clear. You just memorize this one, these two formula you memorize, and you will able to do all the numerical problem. Okay. So let us see, this is the table I had given for all the images which is there in your NCERT book as well. So just go through it, try to make this particular table and write it down, all the cases with the position of the image and the relative size of the image, then the nature of the image. Once or twice if you'll write it, and the diagram will be there in your mind always, and you will be able to do it clearly. Okay. Now this is also a table for your concave lens. Okay, 2 cases I have mentioned as it is given in your book. This is first one, this is second one. So just go through it, and again in this also you have to make again and again, you will be able to remember. Okay. Now some previous year questions, as I told you in this video, I'll show you, I'll discuss. So just some of the very easy questions. This is almost 1 mark question. So just let us practice this one first. Later we will discuss about the numericals. Okay. The question is saying, first one, write the lens formula. It is a direct question. Or the same question can also be given as write the relation between U, V and F of a lens. So don't get confused. This is what the formula is. Okay, it is whatever is the formula. It can be also written in this format of the question. So understanding of the question is most important. Just now we had studied what is the formula, 1 by V minus 1 by U equals to 1 by F. Here you can say, you can extra, I have not written, you can also write what is V, what is U, and what is F. What is V? V is the image distance. U is the what? Object distance. You can say that V is the image distance from the lens, U is the object distance from the lens, and F is the focal length of the lens. Is that clear? Children, let us move on to the next question. State the relationship. Same way it has been given, or directly it can ask also for the magnification or for the lens. You can write. So state the relation between, it is saying height of the object, okay, height of the image, object distance and image distance. So both the formula you have to mention in one question. So m equal to what? H dash by h, because for not to confuse, I have used in case of mirror, it is hi for size of the image or height of the image, and ho for the size or height of the object. Here just it should not be mix-ups. That's why I have written h dash by h. It is there in your NCERT as well, so follow this one. Okay, now it will be, the other formula will be v minus u. As I told you, in case of mirror it is minus, in case of lens it is plus. Let us move on to the next question, children. If on applying Cartesian sign convention for spherical lenses, the image distance obtained is negative, state the significance of the negative sign. It is saying that the image distance obtained is negative. Okay, so if image distance is negative, that means what? The object the image is formed in front of the lens, isn't it? Whenever it is negative, means what? If it is the lens, okay, sign convention we have already studied. In case of mirror also, the sign convention is similar for lenses as well. See here, this is the direction of the ray, so object must be in front of the lens. If it is saying that the image distance obtained is negative, अगर negative मिला है मतलब क्या, इसी side में, because it is opposite to the, this object distance is always negative, because from the lens we have to calculate, right? So similarly, if object is negative, that means the image is negative, that means what? Image distance is negative, means image must have formed on this side, you have to calculate like this, so it has to be negative. I hope this is clear. So this is what it has been written here. Negative sign with image distance signifies that the image formed on the same side of the object is placed, or image formed in front of the lenses. I hope this one is clear, children. Let us move on to the next question. Both spherical mirror and thin spherical lens. Again, you have to be very clear about this. It must be, because here it has been mentioned spherical, the question must be asking about the type of mirror and lenses. Okay, have a focal length of minus 15 centimeter. I have been telling you that if the focal length is minus, then what type of mirror or lens it will be? So mirror is concave. I told you about the mirror, it is concave. So here also, in case of lens also, the lens will be concave lens. For the focal length value, it will be negative in case of concave, whether it is a mirror or lens. Children, I told you about the image formation in case of concave mirror and convex lens will be similar. Okay, but these values like negative for focal length, it is all similar for both the cases of your mirror and lenses. I hope it is clear. Now let us move on to the next question, that is question number 5. Name the part of the lens through which area of light passes without suffering or deviation. Suffering means it is talking about the refraction. Okay, so deviation कहाँ से नहीं होता? Optical center. Just we had studied about the third rule, isn't it? Third rule में लिखा हुआ है optical center में undeviated pass कर जाता है, right? Now next question. डिफाइन प्रिंसिपल फोकस ऑफ ए कॉन्केव लेंस. कॉन्केव लेंस मतलब क्या? इस केस में अपीयर करता है, तो ये चीज़ लिखना जरूरी है. इफ इट इज आस्क्ड इन द क्वेश्चन पर्टिकुलरली बाय गिविंग द लेंस टाइप, सो यू हैव टू मेंशन अकॉर्डिंगली. ओके, सो व्हाट विल बी द आंसर? ए पॉइंट ऑन द प्रिंसिपल एक्सिस ऑफ ए कॉन्केव लेंस वेयर ऑल रेज ऑफ लाइट पैरेलल टू द प्रिंसिपल एक्सिस अपीयर टू मीट. ये इंपॉर्टेंट है, अपीयर टू मीट आफ्टर रिफ्रैक्शन थ्रू द लेंस. ये एक्चुअली मीट नहीं करता है, अपीयर टू मीट, ये पॉइंट आपको लिखना जरूरी है. इज कॉल्ड प्रिंसिपल फोकस ऑफ द कॉन्केव लेंस. आई होप यू कैन रिमेंबर दिस. ट्राई टू राइट डाउन once or twice, so it will be quite clear. Now this is a question, it's a logical question, children. I can see from some option it has been given. An object is placed at the following distances from a convex lens. ठीक है, एक convex lens है, इसमें से इसका focal length है f इक्वल टू कितना? f इक्वल टू है 15. ओके, कॉन्वेक्स है तो ये माइनस तो होगा नहीं, तो ये कॉन्वेक्स लेंस है, तो सिर्फ हमें पॉजिटिव लेंगे 15 सेंटीमीटर. ओके, सो अब ये 4 ऑप्शंस दिया गया है. यहाँ से बोलना है विच पोजीशन ऑफ द ऑब्जेक्ट विल प्रोड्यूस एन इमेज ऑफ सेम साइज दैट ऑफ द ऑब्जेक्ट. सेम साइज हमारा ये कॉन्वेक्स लेंस में कहाँ बनता है? अगर ये ऑप्टिकल सेंटर है, ये है O, यहाँ अगर हमने लिया F1, ओके, ये अगर हुआ F1, तो इसका जस्ट डबल होगा कहाँ पे? 2F1 सेंटर ऑफ कर्वेचर भी है, बट यहाँ लेंस केस है तो हम 2F1 को ही लेंगे. लेट मी ड्रॉ इट लिटिल क्लियर. ये है लेंस, ठीक है, लेंस को ये प्रिंसिपल एक्सिस है, ये है आपका ऑप्टिकल सेंटर O, ठीक है, ये है आपका F1 एंड देन जस्ट इसका डबल हम लेंगे कितना 2f1. ओके. नाउ चिल्ड्रन, इसने कहा ये फोकल लेंथ, ये डिस्टेंस है 15. ओके, 15 है. अब उसने कहा है कहाँ पे सेम साइज का ऑब्जेक्ट कहाँ रखने से, कौन से पोजीशन में रखने से ऑब्जेक्ट का साइज सिमिलर होगा इमेज के साइज के साथ. ठीक है, तो हम जानते हैं ये 2f1 पोजीशन में ही ये दोनों का सेम होता है, तो 2f1 का वैल्यू हमें निकालनी है. ऑब्जेक्ट को ये अगर 15 है तो ये क्या होगा, ये 2 into 15 दैट इज 30. ऑब्वियसली द ऑप्शन 2 will be correct. I hope it is clear, children. This is what written. Just go through it. You will able to answer. Okay. Now let us move on to the next one. Again, it is a definition. You have to remember, as I told you, define focal length of a lens. Okay. Define focal length of a lens. The distance between the optical center and principal axis. Just now we discussed the distance between the optical center and the principal focus of a lens is called focal length of the lens. Okay. Now let us move on to the next question. That is question number 9. A convex lens of focal length 20. फोकल लेंथ दिया है, ये कॉन्वेक्स है, तो फोकल लेंथ क्या होगा, इट इज +20. ओके, वी नीड नॉट टू मेंशन इट माइनस. कैन प्रोड्यूस ए मैग्नीफाइड वर्चुअल एज वेल एज रियल इमेज. ओके, हम जानते हैं कि कॉन्वेक्स लेंस तो दोनों ही प्रोड्यूस करता है, लाइक आवर कॉनकेव मिरर, राइट. इज दिस ए करेक्ट स्टेटमेंट, क्या ये करेक्ट है? इफ यस, वेयर शैल द ऑब्जेक्ट बी प्लेस्ड इन ईच केस ऑफ द ऑब्टेनिंग दिस इमेज. हम जानते हैं ये कॉन्वेक्स लेंस है, ये है कॉन्वेक्स लेंस चिल्ड्रन, और ये मैं ड्रॉ की प्रिंसिपल एक्सिस, ये हो गया आपका ऑप्टिकल सेंटर, ये हो गया ऑप्टिकल सेंटर, ये हो गया f1. ठीक है, ये हो गया उसका डबल 2f1. होप इट इज़ क्लियर. नाउ इसने कहा है ये है 20, ये 20, तो हम ऑब्जेक्ट को ये इसने कहा है कि ये दोनों बना सकता है, दोनों मैग्नीफाइड, मतलब मैग्नीफाइड वर्चुअल, एनलार्ज और वर्चुअल और रियल इमेज बना सकता है. इज इट पॉसिबल? येस, इट इज़ पॉसिबल. कौन सा केस में होता है? लाइक देखो, एक कॉन्वेक्स लेंस का अगर फोकल लेंथ है 20 सेंटीमीटर, तो ये मैग्नीफाइड और वर्चुअल किस केस में बनाएगा, जब हम ऑब्जेक्ट को इस बीच में रखेंगे, ऑप्टिकल सेंटर और फोकस के पास रखेंगे, तो क्या होगा, नेचर ऑफ द रिफ्रैक्टेड रे हो जाएगा डाइवर्जिंग, तो हमको सेम साइज में करना होगा, सेम साइड में हमको उसको मीट कराना पड़ेगा, जो कि वर्चुअल होता है एंड एनलार्ज भी होता है. ठीक है, तो ये हो गया, बहुत पास हम लेंस के लेके आएंगे, कितने पास, इट शुड बी बिटवीन ऑप्टिकल सेंटर एंड f1. ओके, सो यही चीज़ लिखा गया है. और देन ये और एक केस दिया है कि रियल बना सकता है. यस, रियल में तो बहुत सारा केसेस है, डिमिनिश्ड भी है, इक्वल साइज भी है, एनलार्ज भी है. तो हम अब कहाँ रखेंगे, अगर ये 20 है, दिस डिस्टेंस इज 20, तो दिस डिस्टेंस मस्ट बी व्हाट, यहाँ तक के डिस्टेंस कितना है 40. तो हम अगर यहाँ तक देखो, ये अगर ऑब्जेक्ट को हम कहाँ पे, यहाँ जब ये ऑब्जेक्ट यहाँ रहता है तो इमेज का साइज सेम रहता है, राइट. तो हमको ऑब्जेक्ट को कहाँ रखना पड़ेगा, और अगर इसके बियॉन्ड रखते हैं, इसके बियॉन्ड रखते हैं यहाँ पे, और एक केस होता है कहाँ पे, इन्फिनिटी, ये दोनों केसेस में डिमिनिश्ड हो जाता है. ठीक है, तो हम कहाँ, और f1 और इधर f1 के पास, इधर f1 को क्रॉस करके अगर ऑप्टिकल सेंटर की तरफ ऑब्जेक्ट को रखते हैं तो ये वर्चुअल हो जाता है. तो हमको ऑब्जेक्ट को कहाँ रखना पड़ेगा, ग्रेटर देन 20 सेंटीमीटर एंड लेस देन 40 सेंटीमीटर. मतलब हमको इसी बीच में रखने से हमें क्या मिलेगा, एक रियल इमेज मिलेगा और एनलार्ज भी मिलेगा. Children, now you just go through this answer. I know that you will be able to answer it by your own. Okay. Now question number 10. It is just a differentiation between the convex lens, which is converging in nature, and a concave lens that is diverging in nature, right? So all the differences, all the possible differences that we have already during the explanation we discussed. Some of the extra, like your focal length is whether it is a positive, negative, this already I have mentioned in this. So you just go through it, all the 5 points, and try to learn this. This is also quite important. This question already there in the previous year. So children, I hope this will be helpful. In further video we will discuss about the power of lenses, some numericals and so on, right? So till then, take care, bye bye.